Hi, this is Bernard Brolt, and I'm doing this video in response to a comment I had on a previous video I made on ocean rise, and I made the claim that there was no acceleration. I could not detect acceleration in ocean rise, and the technique I used, somebody commented that somehow what I was doing is just noise, and I was amplifying the noise and so on. And I said I'd come back about noise amplification. So this is a video with respect to that. So here's the original ocean height data points. This is data from University of Colorado. So this is real data, and it's right there. It's plotted right here, and the claim I made was that there's no acceleration in this data. And here's the linear regression across the data points. And so what I'm going to do now is I'm going to reuse the same technique with fabricated data, and I'm going to fabricate data with acceleration. So I'm going to force an acceleration signal into it, and I'll use, let me show you how I fabricate the data. So the acceleration signal that I'm going to use is shown here. So 0.05, an increase of 0.05 millimeter in rate, right? So 0.05 millimeter per square year. So in other words, what you would see here, if that was the case, if I use a similar trend and a similar starting point, is you'd start at minus 35, and instead of ending up, you see here, you see this, you know, the increase sort of it looks like it's no longer linear, and the data ends up at 60 instead of like somewhere around 50 right there, right? So starts in the same point. Here's the acceleration that I put into it, and it's a nice, you know, line because there's no noise into it. So let's add some noise. So in order to be fair, what I'm going to do is look at the residuals here between the regression red line and the actual data point, and I'm going to calculate what these residuals are. And here's in this column, that's the residuals. And what I did is I looked at the standard deviation of the residual, and Excel does easy math on that. Here's the standard deviation on it. So it's 4.11. So what I'm going to do is I'm going to add a noise signal. And here's the noise signal, and the noise signal, here's the Excel formula that you see right there, will have zero mean and the same standard deviation as the noise, or if you want the residual standard deviation in terms of ocean height. And the resulting plot is the one at the bottom down there. Whoops, let me just go down here, and here's my fabricated noisy signal. And here it is, right? So as you can see here, the sort of like the fluctuation around some kind of a trend line is, you know, similar to this one right there, because, you know, I'm using statistically something similar. So it's quite noisy. Now the question is, using the same technique that I used to study the actual data, and here's the actual data, and I use, you know, sort of like simple, I would say, simple filtering and simple signal processing, using low-pass filters and so on, and derivatives. Now the claim is that, you know, I'm generating too much noise and I can't extract the data out of it. So this time around, I'll do the exact same analysis on this data here, for which I know what the acceleration is because I built it, plus added quite a bit of noise to it, right? And you could see here that the acceleration is, you know, you clearly see the parabola here, which somebody claimed before that they could see, but I couldn't see it. So I go here to the same technique, right? And here's the acceleration signal is down there, and here's, you know, my result signal that I'm extracting from that data. And as you can see here, it's like it obviously doesn't track this 100%. It just, you know, it's not that powerful. But you can see that it's hovering right around the 0.05. Now, if there was no acceleration whatsoever, I could set this to 0 right there. Whoop. Sorry, let me go back here. Set that to 0. And now you see that 0 acceleration. If I go back to my data points, it's just a pure straight line with noise. And using the same technique, as you can see, definitely is somewhat noisy, yes, but definitely noisy around a zero trend. Now if I give it a very small amount of sea rise acceleration, talking about 0.01 millimeter, right? 0.01 millimeter. What is that? 10 micrometer per year? Wow. I mean, that's not much, is it? So 0.01. Let's see if I can detect that. Look at that. All right. Well. Looks like it's no longer, hovering around 0.01. Can be done. Yes. All right. Thank you very much. Thanks for watching.